Pluto is a fascinating and mysterious celestial body that resides beyond Neptune within the Kuiper belt. While it was once regarded as the ninth planet in our solar system, its status was redefined in 2006 when it was officially reclassified as a dwarf planet. From the outset, Pluto seemed out of place. Its orbit intersects those of other planets, a behavior atypical for a planet. However, this fact has not lessened the intrigue surrounding this extraordinary object in space. As we look beyond Earth in our quest for life, Pluto stands out as an interesting and potentially promising candidate. Despite being traditionally considered inhospitable to life, recent discoveries, both on its surface and beneath its icy shell, have surpassed our expectations. Stunning images taken by the New Horizons spacecraft and the James Webb Space Telescope are reshaping our understanding of Pluto, revealing it to be much more than a mere dwarf planet. These findings have caught the attention of scientists because they do not conform to what was once believed to be true. As we delve deeper into Pluto's concealed mysteries, questions arise about the size of this overlooked world in comparison to Earth. Is Pluto really as small as 1/1000/1/10, 000th, or even 1/1/000,000th of Earth size? This inquiry prompts us to reconsider Pluto's true nature and scale in the grand cosmos. The theory of a subsurface ocean beneath Pluto's frozen exterior has gained traction thanks to the discovery of extensional fractures and the scarcity of significant craters in specific regions. These factors suggest more recent geological activity than previously anticipated. Although this theory is not new, it was first proposed in scientific papers in 2006. Speculations about the potential for surface oceans on various celestial bodies beyond the gas giants, including Pluto, have continued. The arrival of NASA's New Horizons mission in 2015 provided unprecedented images and data that fueled further speculation. When the probe reached Pluto, it delivered the first close-up images of one of the most intriguing objects in our solar system, unveiling a surface marked by fissures, ice volcanoes, and a vast heart-shaped basin. These revelations have led some scientists to hypothesize that even more astonishing phenomena might be hidden beneath Pluto's surface. For instance, an analysis of images taken by New Horizons revealed an icy basin known as Plum located almost directly opposite Pluto's largest moon, Charon. While this could be a mere coincidence, the likelihood is low. Only 5% of models suggest such a formation without any interaction between Pluto's surface and a subsurface ocean. When Pluto's nitrogen-rich atmosphere cooled and solidified, the nitrogen gas accumulated in the basin, generating a weight that caused Pluto to shift into its present alignment. The idea of a subsurface ocean has persisted over the years, and images of Pluto's far side have strengthened this hypothesis. Strong evidence of such an ocean has been found in the form of a feature known as chaotic terrain, a landscape marked by jagged cracks and disordered plains. This terrain is located on the opposite side of Pluto from the basin known as Sputnik Planitia. Scientists have observed similar phenomena on other bodies like Mars, Mercury, and Europa, one of Jupiter's moons. On those planets and moons, asteroid or comet impacts are thought to have generated seismic waves that converged on the far side, causing a similar chaotic terrain to that found on Pluto. Alden Denton, a graduate student in planetary geology at Purdue University, simulated how an asteroid impact could send shock waves through Pluto. The simulations yielded scientifically plausible results, suggesting that such a collision would only have been possible if Pluto had a liquid ocean beneath its surface. Oliver White, a planetary scientist at the SETI Institute in California, also conducted a geologic survey of Pluto, though he did not participate in the earlier study. While the features observed on Pluto's far side resemble those seen on other planets in the solar system, the low resolution of the images leaves some uncertainty. Nevertheless, there is a general consensus among scientists that Pluto displays unique geological features, including a large number of cracks on its far side, which raises the possibility of a hidden ocean beneath its surface. Theories about Pluto's ocean have long suggested that it was once a liquid ocean that froze over due to heat generated by radioactive decay in a rocky core. In this scenario, as the ice melted, it would have caused the surface to wrinkle, similar to the way wrinkles form on an apple left in the fridge. These wrinkles would have occurred due to the contraction of ice as it melted and expanded as it refroze, creating cracks in the surface. If this theory holds, the images from the New Horizons mission should show both older wrinkles and more recent cracks. However, the data from the mission primarily show cracks, suggesting that Pluto's surface oceans may have initially been liquid and then gradually frozen. Observations from New Horizons also revealed a giant rift running across Pluto's near side, extending from the North Pole to the South Pole. This feature, known as the Pluto Rift, doesn't suggest a sudden surface transformation, but rather points to the continued expansion of a frozen ocean. The presence of water on Pluto is further supported by observations of water molecules on the planet's near side, which appear to contain organic molecules. While the presence of water on Pluto might seem unlikely, laboratory experiments have demonstrated that solar and cosmic radiation can produce complex organic compounds, including bases found in RNA and DNA. These findings strengthen the idea that Pluto could harbor organic molecules and potentially support life. Additionally, the probe's observations revealed a reddish band near Pluto's equator, possibly composed of organic material and corresponding to a region receiving more solar exposure and warmer temperatures. This discovery is significant because it indicates the presence of liquid water and organic molecules, two critical components for life. On the other hand, some UFO enthusiasts have suggested that Pluto could harbor artificial structures, pointing to anomalies seen in images of the dwarf planet, such as a smoky trail visible on its surface. While NASA attributes these anomalies to natural processes, some speculate that they might be evidence of extraterrestrial life on Pluto. Despite the exciting discoveries and the potential for hidden mysteries on Pluto, it's essential to remain cautious when interpreting such findings. While the evidence for a subsurface ocean and organic materials is intriguing, much of Pluto's environment remains harsh and inhospitable to life as we know it. Temperatures on the surface are incredibly cold, averaging around 375 degrees Fahrenheit, 225 degrees Celsius, far too low for liquid water to exist in its normal state. Yet the possibility that some form of liquid could exist beneath its icy shell, kept warm by internal heat from radioactive decay or tidal forces, makes Pluto's geophysical features all the more compelling. The notion of life beyond Earth has always fascinated scientists and the public alike. With Pluto's surprising features, many are beginning to wonder whether there may be more to this dwarf planet than initially assumed. If Pluto's subsurface environment does harbor liquid water and organic molecules, it may not be so different from other icy moons in our solar system that show promise for microbial life. The presence of a potential ocean beneath Pluto's icy surface, combined with the detection of organic compounds, may lead to new discussions about the requirements for life in extreme conditions. Pluto's place in our solar system remains a topic of debate as scientists continue to study its characteristics and uncover more about its origins. The idea that a once distant cold and lifeless body could potentially house organic materials, or even an ocean beneath its surface, challenges our preconceptions about habitability in extreme environments. It also opens up new possibilities for astrobiology, suggesting that life could potentially exist in places once thought to be too inhospitable. As technology advances and more missions like New Horizons continue to provide detailed observations, our understanding of Pluto and the potential for life in the outer reaches of our solar system will undoubtedly evolve. Whether it's the intriguing possibility of a subsurface ocean or the detection of organic molecules, Pluto remains a focal point for future research and discovery. Its mysterious and enigmatic nature continues to captivate scientists, and as we gather more data, Pluto may one day reveal even more secrets that could change the way we think about life beyond Earth. Future exploration of Pluto. Despite its classification as a dwarf planet, Pluto remains one of the most intriguing celestial bodies in our solar system. The discoveries made by New Horizons have only scratched the surface of what Pluto may hold, prompting discussions about future missions to explore this distant world in more detail. Potential for a Pluto orbiter. Many scientists advocate for a Pluto orbiter mission, which would allow for prolonged observations rather than the brief flyby that New Horizons conducted. A spacecraft capable of entering orbit around Pluto could map its surface in high resolution, analyze its atmospheric changes over time, and even search for signs of an active subsurface ocean. Such a mission would require significant advancements in propulsion and energy storage, as Pluto's extreme distance from the Sun makes solar power inefficient. Nuclear-powered spacecraft like the Voyager probes could provide a viable solution. One of the main goals of a Pluto orbiter would be to confirm whether an ocean lies beneath its icy crust. Using radar instruments similar to those used to study Jupiter's moon Europa, scientists could determine the thickness of Pluto's ice shell and detect any subsurface liquid water. If a Pluto ocean exists, it would be among the most distant known reservoirs of water in the solar system, a crucial element in the search for life. Pluto's moons and their mysteries. Beyond Pluto itself, its 5 known moons, Charon, Nix, Hydra, Kerberos, and Styx, also hold scientific significance. Charon, Pluto's largest moon, is particularly interesting due to its complex surface and deep chasms which suggest a history of tectonic activity. Unlike Pluto, Charon lacks a significant atmosphere, but its surface composition hints at past interactions with Pluto's escaping gases.